The following is an overview of the background, research, and need for technological innovations in online learning. This video focuses on using simulations or virtual environments as teaching tools at the undergraduate and graduate level online university. The following presentation will follow Everett Rogers' Diffusion of Innovation Theory. The four phases for integrating simulations into our online classes that will be presented here are knowledge, persuasion, decision, and implementation. What is simulation and why is it used? Simulation is often used in the training of civilian and military personnel. This virtual training usually occurs when it is too expensive or too dangerous to allow trainees to use real equipment. In such situations, the learners will spend time experiencing real-life lessons in a safe, controlled environment. There are four main types of simulation. Live simulation, where real people use dummy equipment in the real world, for example, CPR training. Virtual simulation, where real people use simulated equipment in a virtual environment. Constructive simulation, where simulated people use replicated equipment in a virtual environment, for example, games such as World of Warcraft or Second Life. And augmented reality, the next wave of simulation, where users are transported into a holographic virtual world that can be interacted with and manipulated by the user. The first simulation game may have been created as early as 1947 by Thomas T. Goldsmith Jr. and Ethel Ray Mann. This was a straightforward game that simulated a missile being fired at a target. The curve of the missile and its speed could be adjusted using several knobs. In 1958, a computer game called Tennis for Two was created by Willie Higginbotham, which simulated a tennis game between two players who could both play at the same time using hand controls and was displayed on an oscilloscope. This was one of the first electronic video games to use a graphical display. Simulations have been used increasingly since antiquity. With advancement in technology, there has been little to no downward trajectory of virtual reality across all fields. In the early 1900s, simulations were used in medical practice and were made from natural resources such as clay and stone. Distance learning became popular with correspondence learning as hands-on materials were sent to learners via mail. In the 1940s and 50s, mannequins began to mainstream for medical simulations. The 50s and 60s prompted advancement of military simulations for combat-related training. In the 1960s, distance learning modernized with technological advancement. Delivery methods included radio, phone, and television. In the 1970s, body-mounted virtual simulators became present and video games mainstreamed. In the 80s, medical simulations begin to become computerized and data begins to be used to predict outcomes, which leads into the 90s when scientists promoted interactivity for showcasing scientific data such as predicting climate and global changes. In the late 1990s, the internet begins to take over as the main distance learning delivery method. Most courses are text-based. Driving simulators, wargaming, and flight simulators become popular. The blockbuster movie The Matrix showcases virtual reality. In the 21st century, medical simulators blend mannequins with computers to create live patient training on robots. Database games such as CapSim enter the e-learning environment. Students demand more of e-learning to keep up with the interactive world, and the Second Life virtual reality program enhances the online college lecture experience. Reviews of teacher education programs continually report on a number of key skills that are not well developed by traditional schooling. These include student discipline, motivating students, dealing with individual differences, insufficient and/or inadequate resources, organization of classwork, assessing student work, and relationships with parents. Programs such as SimSchool present cases that allow students to practice applying theory to their instructional decision-making in a virtual classroom environment. Simulation-based learning can be used to teach communication skills, negotiations, and dealing with challenging people or situations. In order for simulation-based learning to diffuse successfully at Ottawa University, the process of adoption would follow these four phases. The promotion of the idea to the Dean of Online Education and the Academic Affairs Specialist. The research of methods, delivery cost, and software packages. The showcase success at other universities. Create models and mock-ups for courses as samples. Decisions would be made by the Deans of Online Education. Software purchases and analysis of which course to place the first simulation in. The adoption and encourage all courses to have at least one scenario-based learning exercise. Why should we incorporate virtual reality into our classrooms? The classroom of the future will probably contain several kinds of simulators in addition to textual and visual learning tools. This will allow students to enter the workplace better prepared and with a higher skill level. The students will have a more inclusive method of retraining or of incorporating new procedures into their profession, and regulatory bodies will find it easier to assess the proficiency and competency of individuals. With a growing presence in the online world, universities like local competitor Grand Canyon University have created and integrated a variety of innovative visual enhancements into many of its online classes. Through a combination of 3D models, simulation, flash movies, audio lectures, recordings, and a fresh, more visually appealing design to the online learning environment, GCU is quickly becoming a powerhouse in the online education industry. Other universities are using simulations as well. The following is an example of a simulation-based activity currently in use at the University of Maryland.
The purpose of the game is to have a summative activity in the Introduction to Criminalistics course, which instructs students in practical, real-life concepts related to crime scene evaluation and physical evidence examination. Students a chance to put the knowledge learned from the course into practice in a non-threatening way, while still giving students a chance to see the consequences of their actions. Mistakes can be made in the simulated crime scene without jeopardizing an investigation that's in progress.
SimSchool is a classroom simulation that supports a teacher training program. SimSchool users are able to personalize their own virtual classroom, the number of students, their personalities, and the variable learning styles within the student body. When using SimSchool, the teacher is able to virtually interact with students by asking behavioral and cognitively challenging questions and make observations based on the student's reaction. When the simulation is over, data is produced that represents the student's level of academic and behavioral contentment based on the student-teacher interaction. A key step during the adopting of an innovation is to identify the personnel who will propel the innovation through the diffusion process. The innovators and adopters identified at Ottawa University are as follows. The innovators would be the online curriculum development team. The early adopters would be the deans of online education. The early majority would be the online instructors. The late majority would be the upper management who are in control of the budget, and the laggards would be the ground instructors who are transitioning to teaching online. The innovators are convinced simulation would enhance courses. Given the tools, they would create course examples to showcase their ideas. The early adopters are also in favor of advancing the course design, but have to convince upper management due to budgetary restraints. They rely on the innovators to visualize their ideas for budget approval. The early majority are in favor of enhancing the courses, but may be slow to adopt the new technology in the classes. Extended trainings and mentors would help to communicate the benefits of interactivity in the course. The late majority, the heads of the university, fall into this category because of financial and planning constraints. Given an unlimited budget, these individuals would adopt the innovation immediately to stay competitive with other universities. The laggards, or old school professors, are slow to adopt this innovation. Given the right training and example of the benefits, however, they will be willing to adopt, but may not use it themselves. Key change agents in the adoption are as follows. The curriculum designers who have the ability to incorporate simulations into courses and create models to showcase the innovation. The deans have the influence over the faculty to push for a wide majority of acceptance, and the students have the influence of input. Their satisfaction in the course incites word-of-mouth praise and increased enrollment. Adopting simulations into the online college would be a decentralized process. Everyone in the university shares in the control. Curriculum developers develop simulation for trial classes. Based on the info from trials, university governance decides which courses lend themselves to immediate adoption of simulations. IT department inputs perceived needs and problems. Designers adapt and reinvent the course simulations as they diffuse. Faculty input determines usability from a teaching standpoint. Student input determines effectiveness from a student standpoint. University governance determines need for advanced technology systems, specialized Flash developers, or new employees. And marketing determines approaches to garner potential students. Critical mass becomes virtually unstoppable at 10 to 20% adoption rate because when this level has been reached, the innovation can be spread to the rest of the social system by way of momentum. The concept of critical mass implies that activity should be concentrated on getting the use of the innovation to the point of critical mass where it will then be self-propelled. Early adopters are key to the successful diffusion of an innovation because of their ability to propel the system to critical mass. With technology evolving at a rapid-fire pace, one might wonder, once we adopt this innovation, what happens next? In the not-so-distant future, learners will soon be immersed in a different type of simulation called augmented reality, in which the surrounding real world of the user or learner becomes interactive and digitally usable with the help of head-mounted displays, 3D glasses, or virtual retinal displays. Imagine a PC screen where program windows and icons appear as virtual devices in real space and are eye or gesture operated by gazing or pointing. In this future classroom, imagine an architect rebuilding holographic ruins as they once existed, an education major tutoring simulated students, a police science major walking into a virtual crime scene, or a business major addressing his simulated employees in a team meeting. In order to reach this height of simulation, we need to jump in at the ground level and develop educational materials that reflect our changing times. The possibilities are endless. In the real world, variance happens. To better prepare students for real-world expectations, we should be introducing them to the complex problems that may arise after they leave higher education and move into the workforce. Simulation is an indispensable problem-solving methodology. Today's generation of technology-savvy students are demanding more than a text-based class. They seek interactivity, engagement, and most importantly, preparation to advance in highly competitive job markets. Realistic graphical representations immerse the students in hands-on application and make assessing the students' output and performance all that much easier.